This video will cover the basics of using LabVIEW, and it's primarily going to be the PowerPoint file that is also provided under this video. And in the next video, we will take a look at actually getting started in LabVIEW. But first, I want to give you a kind of a brief overview. First of all, the reason that we are using LabVIEW is that this is standard industry software. So if you get into an industry application where you are taking measurements regularly and trying to store them somewhere, you're probably going to be seeing LabVIEW in that environment. National Instruments has great tutorials available, and I will direct you there via a link on the Brightspace page. If you're having any trouble getting started or finding kind of big picture how to use this tool questions, I would suggest that you check out the National Instruments tutorials. What is LabVIEW? Well, it's a great software package that allows for very simple data acquisition and data processing. I can acquire voltage readings, resistance readings. I can use thermocouples and thermistors and RTDs. I can also measure strain directly. If you'd like to know more about these, do a quick internet search. There's a lot of information out there. We will, by the end of the semester, get through all of these types of data acquisition. The data processing options that we're particularly going to look at is charts, digital readouts, and saving data to file. We're going to start with charts and readouts because those are simplest. And by the end of the semester, you will be able to be saving your data wherever it is you'd like it to be. So some language for LabVIEW. You're going to have a front panel and a block diagram. So your front panel is what the user sees. Okay, if you're the programmer and you hand this program off to a user, maybe it's a technician, maybe it's a customer, or maybe it's just one of your peers or colleagues. This is where the user runs the program, interacts with the information, might see some charts or readouts, and all of your programming goes in the block diagram. So that will be where the information for data acquisition goes, or how data acquisition ends up in a chart or a readout or being saved to a file. When you're here, you have controls on the front panel because the user controls the front panel. And on the block diagram, you have functions because the programmer puts functions into the block diagram. These double arrows extend these toolboxes to give you even more options. So as you expand it, you can see there's a lot of different categories of tools. What we will tend to use is the Express toolbar whenever it has the tools that we need. But you might know that you want to do some, let's see, well, Express is going to have input and output, but on the block diagram, you might not want to know you want to do some programming, some logic, if you will, or you might want to do some mathematics since you're going to poke around in the mathematics tool area. So a lot of options here. There is a handy search box in each of the tool palettes, and that allows you to type in what it is you're trying to do. And it's going to suggest the tools that are closest to it. So if you can say, input on the controls toolbox, it's going to give you all of the input options it knows of. Meanwhile, if I know that I'm trying to add or multiply on my functions toolbar, it's going to get me pretty close to those tools. So this is an example. This was a pretty simple temperature conversion, and you can see I have 3 readouts here. They're actually kind of thermometers. One is my input, and you would only know that by running the program that this is an input. It's a slider. It's kind of being a pretend measurement device, if you will, okay? And then I'm converting that input to Kelvin or degrees Fahrenheit. So for a more real-world application, imagine I'm looking at a physical thermometer in the world, and I'm going to input that here, and I want to know what that means in Kelvin or Fahrenheit. This is my block diagram. There's some logic that allows it to loop until a stop button is pressed. That's a while loop. And I have the addition tool to change my Celsius into Kelvin. That one's nice and easy. And then I made a subroutine or a sub VI imagine like functions in Arduino, and this does the math necessary to get from Celsius to Fahrenheit. Multiply by 9, divide by 5, and add 32. So this is the mathematical steps and the logic steps that needed to happen. And if I was to run this, you would see that as I change my degree Celsius, these two update accordingly. This is just showing you how to search functions. So for example, I want to multiply. Well, I could go to the express numeric palette, the numeric palette. I could find this, that looks like a sub-VI to me. And then there's these other options that might be similar to what I'm trying to do, but this is how the search palette works. So for those of you who are rusty in your programming, keep in mind that on the structures palette, this is where I can put in while loops, for loops, and case structures. So while loops loop indefinitely until a particular criteria has been met. Usually I use while loops with a stop button, but you could certainly use it with you know, looking for a particular type of data point, or looking for a particular amount of time to pass. So maybe I want to collect data for, you know, 3 hours. I could set up a time condition. My for loop is for a finite number of loops. I want 100 data points. I'm going to use a for loop and set my number of loops to 100. Certainly I could constrain a while loop to count loops and stop at 100. For loop is just set up a little bit more straightforward in implementation. A case structure can be binary, true, false. This is like an if-else statement in a C program, but it can also be non-binary. That is, it can have more than 2 options. My case could be a units request, and my options could be Celsius, Kelvin, Fahrenheit. I could have 3 cases in my case structure. So under the programming area of the tool palette, there's the structure palette, and you can hover over any of these tools to see what each one does. Numeric operators are simple nodes that allow inputs and outputs that perform the function as needed. So you'll see add, subtract, multiply, divide. So you can hover over the inputs to see what order they're in. There's also rounding options. There's a compound arithmetic that will allow you to do commutative properties, so add, multiply, or some Boolean operators there that we won't use this semester. And I could add, you know, 15 things together all at the same time. Quotient and remainder, if you don't remember what those are, right? Think back to elementary school division when you got a whole number quotient and a whole number remainder left over, right? This will give you both of those. I can also do conversions between types of numbers, you know, integers, doubles, Booleans. So you can take a look there. I can also change the memory being assigned to each variable. So a lot of options here. And then when we look at the Boolean toolbar, most commonly we're going to use either and or Boolean operators, but I would say this is for advanced programmers who are really comfortable in LabVIEW, and you could easily get out of a mechanical engineering program without ever really using a Boolean operator. This is not crucial, critical programming content, but the idea being, right, and or. So if A and B have to be true, then both A and B have to be true. If A or B has to be true, then either one could be true, and the result would be true. So think about, you know, is it apples and bananas? Well, if it's a bowl of apples and bananas, yes. Is it apples or bananas? Well, that's true if it's apples, a bowl of apples, or a bowl of bananas. Not the most clear, the only option there, but you can give that some read on any programming, including the help file for LabVIEW. Okay, comparison can be quite helpful, especially this switch tool right here. So you can look to see if 2 things are equal or not equal. You can compare a number to 0, helpful for quotients or looking for a particular condition. Switches allow you to check a condition, and if that condition is true, it does one thing, false, it does another. That's handy for saying, like, if I have a calculate switch, It only activates if I've turned the switch on, for example. So a lot of options on the comparison toolbar. And then timing, the reason we would use the timing toolbar is because LabVIEW programs operate as quickly as the computer processor is going to allow it. So we're talking, faster than milliseconds. That means that your user interface is updating faster than every millisecond. You're usually going to want to slow that down in some way, or if not only to make the user interface easier to look at, but also to make sure that you're updating your data at least as often as you're updating your user interface or writing to a file. So you can do a tick count timer, you can wait for a number of milliseconds. I can also ask what time it is. That might be helpful